right. Well, thank you. It's a real honor to be invited to speak here. So thanks to Steve and the crew for the invitation. So let's see. I'm not seeing my slides anywhere. Yeah, here we go. So first I want to start with what I consider the heart of behavioral economic demand analysis. And so this is a perspective I think isn't often, shared when we talk about demand curves in relation to drug reinforcement. I think the heart is that this is a truly multidimensional assessment of reinforcement. And so for context, the prevailing construct that defined drug reinforcement was something known as relative reinforcing efficacy, a concept published in 1979. And it stated this, that you could rank order drugs along a single continuum according to their reinforcing potential, and that you could use different metrics of reinforcement to assess the reinforcing potential of those drugs, whether it be choice procedures or response rate or anything else. And she come up with basically the same answer when rank ordering these different drugs. And if you got different answers, well, there's always experimental error, noise in the data. So it was chalked up to that. But I think what the demand curve analysis has shown us is that, in contrast, that reinforcement is inherently multi-dimensional. And so when I think about the older concept of relative reinforcing efficacy, I sort of think about, early child development. So before the stage that Piaget called conservation. So this classic example where the child sees that two glasses, same size, same amount of water, one's poured in front of the child into a tall, skinnier cylinder. And they're asked, okay, which has more water? And the child says, well, points to the tall, skinny one. Says there's more water there. So the error being that they're attending to a singular dimension, in this case, height. And so this is sort of like relative reinforcing efficacy as a conceptualization of drugs. Now, I like this example because drug reinforcement is analogous to spatial dimensions in this sense. It's not just that we have these random, different ways of measuring space. We know precisely and mathematically how they relate to each other. So we have the height, width, and depth that can be integrated into volume. There's different ways to get at that. If it's round, we can get circumference. But even if we're comparing the same volume by integrating those three dimensions of space of two different liquids, if they differ by density, how do you answer the question, which one is more? Well, one might have greater volume, one might have greater mass. But again, we know how all these things relate. We know how the three dimensions form volume. We know how mass and volume integrate to form density. And so in the same way, we know this about drug reinforcement. So I'll demonstrate that with some research I conducted with Warren Bickel here at the University of Vermont when I was a graduate student. So here we used a procedure that Warren had used previously many times, where dependent cigarette smokers would come into the lab. They haven't smoked for 5 or 6 hours, but they had the opportunity in these 3-hour sessions to earn cigarette puffs by pulling these Lindsley plungers. So it's operant reinforcement. And so over this 3-hour session, I'm showing you in the solid symbols, the filled circles, the classic demand curve for earning cigarette puffs under this context. I'm also showing you, though, other sessions that we conducted with these same people in which the only reinforcer available to be earned was money, a 25-cent reward. And so in the open circles, I'm showing you the data from those sessions, the demand curve for that. And you can see both conform to what we consider the classic demand form function. So at the lower prices in this double logarithmic coordinate axis plotting reinforcers earned versus price, you see that they start out at a relatively, at a, what we consider a preferred consumption level for that reinforcer. And then they essentially defend that level of consumption through escalating prices until at some point where the reductions in consumptions are super proportional to the increases in price. And that we call that the point where it shifts to elasticity, from inelasticity to elasticity. And then the curve drives further downward. So just looking at these data, you can say, well, what's the better reinforcer? Well, at lower prices, looks like money is. At higher prices, looks like cigarettes are the better reinforcer. So another type of output you get from these experiments, taking the same data set, you can look at the response output function. So here it's the same thing as the demand curve, except on the y-axis, instead of reinforcers earned, we have total price paid. In other words, the number of plunger pulls that were emitted. So looking at this, you can see this increasing effort, this increasing number of responses that are emitted in order to defend that preferred level of consumption, until at one point the shift to elasticity where you see the curves turn over. So with this basic framework, we conducted those individual sessions, but we also conducted concurrent sessions in which both of these reinforcers were available at the same price, and other contexts in which we compared the three traditional measures of relative reinforcing efficacy to various metrics of the demand curve. So we found that choice procedures, in other words, the preference level you got under concurrent sessions, corresponded very closely to the relative heights of demand curves when conducted under individual sessions. We found that peak response rate was related to that maximal height of the response output curve. And we found that progressive ratio breakpoint was related to the point at which the demand curve was driven finally to zero. So I'll show you a couple of other studies where we use this a similar technique to explore some other questions. Same experimental setup. In one phase, these cigarette smokers produced a demand curve that I'm showing you here across these sessions for cigarette puffs. But then in another session, we had, in addition to this price manipulated opportunity to earn cigarette puffs, we had the opportunity to earn 1 minute access to nicotine gum as an alternative. Now, the price of nicotine gum, or the number of pulls, was low and fixed throughout. So it was 3 pulls on the plunger. Even though the price was fixed, we saw a sharp increase in the consumption of nicotine gum solely as a product of the increasing price of cigarettes. So that meets one of the behavioral economic definitions of the substitute, this so-called positive cross-price elasticity. In other words, this positive slope that you're seeing there. A similar experiment, we systematically replicated this again with Warren and also Ari Kirschenbaum, who's in the audience today. Those top 2 phases, we basically replicated what we saw in that previous study showing that nicotine gum substituted for regular nicotine-containing cigarettes. But then in the bottom left panel, I'm showing you another phase in which, again, we had different prices. We manipulated the price for nicotine-containing cigarettes, but we had denicotized cigarettes available at a fixed low price throughout instead of nicotine gum. And you see there, like nicotine gum, that positive cross-price elasticity for denicotized cigarettes, showing it to be a substitute as well. And then finally, in the bottom right corner, we see yet another phase in which both denicotized cigarettes and nicotine gum were available as potential alternatives, basically an aspect of the pharmacological and non-pharmacological aspects of cigarette smoking. And we see positive cross-price elasticity for both of these, except stronger for denicotized cigarettes, really highlighting the importance of those non-pharmacological aspects of smoking reinforcement. In this same study, we looked at what I consider another aspect of behavioral economic substitution. That's asking the question, what does just the availability of one of these alternatives do to the consumption of the price manipulated reinforcer? In other words, in this case, how much does it potentially reduce self-administration of full nicotine cigarettes? And you can see that both of those phases, phases 3 and 4, where denicotinized cigarettes were available, whether or not gum was also available, those were the sessions that saw the largest decreases in full nicotine cigarette consumption, suggesting, again, powerful substitution. So more recently, a couple of years ago, my lab published this using the same basic paradigm of operant cigarette demand curves. We looked at this concept of nicotine reduction. You've already heard about it. We're going to hear more about today. Of course, Jack and Neil Benowitz proposed decades ago this idea. Since 2009, it's possible per law to reduce nicotine to less addictive or non-addictive levels to provide some public health benefit. So we explored this idea with this basic, with the setup I've been describing. So in these sessions, we blinded nicotine content across different conditions. Not only that, but we were a little mischievous, we obscured the very fact that nicotine content was even being manipulated. Participants received one of 3 reduced nicotine doses, and that was a between subject variable. The level of nicotine reduction differed across participants. And we assessed these demand curves for full and reduced nicotine cigarettes in individual sessions, like I've described, where they were the only reinforcer available. But then we also looked at the ability of reduced nicotine cigarettes to serve as substitutes for full nicotine cigarettes in the way I've described, where the reduced nicotine cigarettes were available at a fixed low price throughout, and the full nicotine cigarettes were price manipulated. And then we assessed all of the above, everything I've just described, in 2 separate phases. One before a 3-week at-home exposure period and one after that period. And during that home exposure period, they're instructed to only smoke the level, only to smoke the experimental cigarettes. And for 3 of the groups, they received one of the reduced levels of nicotine, the same ones that were the reduced nicotine cigarettes that they were receiving in these lab sessions. And then in a control group, they received experimental cigarettes, but full nicotine during that at-home exposure. So we looked at before and after that home exposure phase to see whether any of those outcomes I described changed as a result of, experience with those cigarettes on a daily basis. So this is one of the ways to look at the data. What I'm showing you here, I apologize, I think the top is cut off, but what we're seeing on the left column is pre-exposure before that 3-week period, and then in the right column, that's post-exposure. The different rows show the different groups of subjects, and so different levels of reduced nicotine cigarettes. And then within each panel, I'm showing you full nicotine cigarette demand versus reduced nicotine cigarette demand. And what I think you can see here is that we found no systematic or significant difference between full or reduced nicotine cigarette demand in any aspect of the demand curve. Showing you the same data here in a slightly different way. And again, I apologize, we're missing the very top of the slides I'm seeing on the screen. But here, the left column is showing full nicotine cigarettes. The right column is showing reduced nicotine cigarettes. And then within each panel, I'm showing you pre-exposure versus post-exposure. So compared to the last slide, here you can more easily compare pre versus post-exposure within each panel. And what we found was, and as you can see, is that we found a reduction in demand post-exposure. But the thing is, that reduction was similar across all the levels of reduced nicotine cigarettes, and we even saw it for the control condition on the top row who received full nicotine cigarettes during that at-home exposure period. And so finally, I'm showing you data here from those substitution sessions where the denicotinized cigarettes were available, or the reduced nicotine cigarettes were available at a fixed low price throughout. On the left, we're showing pre-exposure. On the right, we're showing post-exposure. And so the black symbols are replicating data you've already seen. That's replicating full nicotine cigarette consumption when they're the only reinforcer available in the session. The gray circles are showing, again, full nicotine cigarette consumption but under the conditions under which the reduced nicotine cigarette was available as a substitute during that session. And so you can see the gray symbols are lower, so we did see a decrease in demand because of the availability of the reduced nicotine cigarettes. And then in the open symbols, what we're showing is the consumption of those fixed, low-cost, reduced nicotine cigarettes. And you can see in all the conditions that positive slope, that positive cross-price elasticity, they look like substitutes. But again, we didn't see any difference, and the statistics bore this out, any difference dependent on nicotine dose. So in conclusion from this experiment, at least with this lens, no significant or within subject differences due to nicotine dose effects on any of the demand curve characteristics. Exposure decreased demand for reduced and full nicotine study cigarettes, but that decrease was regardless of level of take-home nicotine dose. Reduced nicotine cigarettes appeared to substitute for full nicotine cigarettes, but overall, the data do question under this model the success of a potential reduced nicotine mandate. Next, I'm going to show you another operant session study conducted in our laboratory exploring this concept of greenwashing. So greenwashing are tactics used by the cigarette industry and a lot of other industries, portraying the products as eco-friendly or natural. And cigarette studies have shown that cigarette smokers, this results in reduced perceived health risks for cigarettes when cigarettes are portrayed in this way. So what we did here was we came up with two novel brands, we made them up, of cigarettes. One was portrayed as greenwashed and one was a matched control. Unbeknownst to the participants, this was another devious aspect, this was the same commercial cigarette. We made sure it was a brand that they weren't used to smoking, but it was the same commercial brand of cigarette portrayed throughout the entire experiment as these two separate brands. And we tested at the end to see, we probed to see whether they kind of figured out what was going on, and none of them did. So it looks like we successfully fooled them. And so here's what we came up with, brands of Victor and Triumph, and I'm proud of these names, and also of our packaging. I have to say, I've never taken a dime of tobacco industry money, but I think I have some potential. I think these would do well. I mean, I think Victor and Triumph, I mean, these are powerful, you know? So what I'm showing you on the left is, in this particular case, Victor is the greenwash brand. So we have the tobacco leaf, we have the verbiage of tobacco, water, and simple. And the smaller text, you probably can't read all this stuff about it being eco-friendly and, you know, grown in a sustainable way and all of this. And it's even, and we know that the cigarette industry, and this has been published, they use all of these tactics. It's even on this, and you may not be able to see it from your vantage point, but even the background sort of has this resemblance of recycled paper. So it looks a little more eco-friendly. And then none of those elements are there for the Triumph brand, but we counterbalanced this such that for half the participants, there was the Triumph brand that was greenwashed, and the Victor that was the match control. And so jumping to the results, this is in the same operant setup where people are responding for one of these two brands in separate sessions. Here are the demand curves. And I do note that unlike the previous demand curves I've shown, the linear axis here, the axis here is linear rather than logarithmic, but that's so you can more easily see the differences. But we found significantly greater consumption of greenwashing cigarettes at those lower prices. A simple demonstration, but I think a powerful one in showing that, you know, greenwashing really increases the reinforcing effects of cigarettes, particularly at lower prices here. And then finally, want to talk a bit about it. A talk wouldn't be complete about demand curves and drug abuse without mentioning purchasing tasks. So these are hypothetical procedures that mirror the operant procedures that I've been describing. So a typical situation, the person's read a vignette, you're in this situation, your only access to this whatever product today is this source. How much would you buy at this cheap price, at this price, at this price, at this long list of prices? And from those various consumption levels that they provide, we construct demand curves. And so the first instance of this was conducted here at University of Vermont, Eric Jacobs and Warren Bickel, looking at cigarette versus heroin demand in people who like to use both. And as you could see from this example, at the lower prices, cigarettes had higher demand, but that shifted. Heroin had higher demand at higher prices. So very quickly, with a couple of minutes left, I'll show you just one example from our lab where we've applied these hypothetical purchasing task techniques. This is also has some relationship with the nicotine reduction mandate idea. In this case, we asked the question how people would respond to black market cigarettes in the context of a reduced nicotine mandate. And I'll jump to the results here. Same, situation where they're responding to how much they would respond at these various prices for these various products. One condition was symbolized in the solid symbols. Just right now, your normal brand of cigarette. We're not even talking about any nicotine reduction mandate. How much would you consume your normal cigarettes? There's the demand curve for that. Then in the open circles, I'm showing you how many reduced nicotine standard cigarettes they would consume in a post-mandate world. And here you see the highest level of demand, probably, and I'm speculating here, probably some anticipated compensatory consumption to get a preferred nicotine level. And then finally, I think most interestingly, in the triangles, we're showing you illicit full nicotine cigarettes that they could get a hold of. And you see at the lower prices, really identical on average consumption to their usual brown cigarettes, although that consumption drops off at higher prices. But I'm most struck, even though we saw the lowest demand for these, that this is pretty sizable levels of consumption. So it's something we really need to take seriously, is this potential increase in the black market for cigarettes in consumption. And I wasn't going to mention this aspect, but inspired by something Jack mentioned, we did find in another aspect, you can look at the paper, that when e-cigarettes were available, that we were able to not eliminate, but to reduce the consumption of illicit full nicotine cigarettes. So the availability of the appropriate substitute is key, as he was hinting to. So overall, I'll sum up about the demand analysis of drugs. Demand curves have introduced an understanding of drug reinforcement, and I would say reinforcement itself goes beyond drugs, as an inherently multidimensional construct. It's allowed for a comprehensive comparison across drugs and other reinforcers. It's allowed for an understanding of reinforcer interactions, such as the substitution relationships I've been describing. And finally, demand analysis is widely applicable to abuse liability assessment across substances, and particularly, I'd say, tobacco regulatory science. And so with that, I'll thank a number of contributors to the various studies I've shown you, including Justin, who's also in the room. And thank you all for your attention.
So the question and answer period. Our next speaker is Dr. Greg Madden from Utah State University. Just a reminder that we're going to hold off on the question and answers until the period for question and answers at the end of the session.
So I'd like to begin by recognizing that this line of research that I'm going to talk to you today about, it really began in the mid-90s when I was a postdoc working under Warren Bickel. And Warren had a massive impact on my life and my career, and I just can't recognize him enough before I give him this talk. So I'm going to talk today about impulsive choice, which is one of the facets of impulsivity. But in this specific facet, we're talking about an impulsive choice occurs when there's preference for a smaller, sooner reward, which is given here, SSR. It doesn't show up on the screen. And so it's smaller because that green bar is lower than the red bar. The red bar is the larger later reward. And it's larger because of the height of the bar, and it's also later because of the delay that's imposed between time t1, which is where the choice is made. And so the choice is, which would you rather have, the smaller sooner or the larger later? The impulsive choice is to choose the smaller sooner. So one mechanism by which this occurs is the discounting of the delayed reward. And this hyperbolic discounting curve that's shown here declines very steeply in this case as a function of the delay until it is received, such that at time t1, that rather large beach ball sized red dot there shows the discounted value of the larger later reward at time t1, where the individual is choosing between the smaller sooner and the larger later reward. Now, because the discounted value is so much lower than the smaller sooner reward, the impulsive choice is made. For other individuals, the shape of the discounting function, it's still hyperbolic, but it's less steep. And so with shallow discounting, the subjective value of the larger later reward retains most of its value and is preferred to the smaller sooner reward as a result. So back in, I think it was like 1996, Warren Bickle and Nancy Petrie and I were all at a bar because Warren would take some of his time and read articles with his postdocs and meet with us and talk about new research ideas. Warren was always looking for new, novel, innovative research ideas. And so we read an article about delay discounting, and all three of us said, oh, we have got to see if this is related to substance use disorders. And so this is the result of that evening in the bar. And what you can see is steeper discounting of hypothetical monetary rewards in the individuals with a heroin use disorder relative to a matched control group, which is shown as the triangles. Now, the matched control group was matched on everything that we could think of that could potentially impact delay discounting. So their income, their education, we even had a short IQ test to make that matched as well. Now, in the years that followed, many replications of this have occurred, and this is just one of the meta-analyses that shows that there is a relation between steep delay discounting and substance use disorders of all types. But it's also related to, as Matt Johnson has showed, risky sexual practices. Warren and I and Amy Odom did some work on risky drug use, like needle sharing activities, but also all of these other disorders that negatively impact human health. There's some evidence to suggest that from longitudinal studies that the steep delay discounting comes first, and then subsequently leads to early cigarette smoking, early alcohol use, and other substance use disorders. So about 10 years ago, the director of NIDA wrote this: interventions focused on strengthening the ability to delay gratification or improve self-control, which means choose the larger later reward. These could help better prevent a wide range of negative behavioral health outcomes. So all of that amassed evidence from many meta-analyses now shows this relation between steep delay discounting and all of these negative health impacting behaviors. And so what the director of NIDA is calling for is prevention research. And so when I read that, I started thinking about what I was doing in the lab. So I'd been working for about 5 years then on ways to reduce impulsive choice in rodents. And so I started thinking about what might an ideal prevention program look like. Well, I thought if we're going to do this, we ought to do it in an early intervention way with children, young children, because when you talk to teachers, they already point to impulse control problems, even when the kids are in preschool. And the teachers talk amongst themselves about the impulse control problems of the children, such that when they pass them off to the next teacher, they already know the reputation of this child. And so an early intervention program would be best. Now, let me just say up front, I don't have that early intervention program. Don't get your hopes up, but we're working on it. I've also done a fair amount of research in schools, behavioral economic research in schools, to try to get kids to eat fruits and vegetables, whole different research line. But one of the things that I learned in doing that research is if your intervention is not low cost, the schools are not interested in doing your intervention. It also needs to be fast acting, because if it takes forever to get any results out of it, again, they're just not going to sign up for those interventions. And it should be efficient as well. So we're beginning now to work in schools with children to try to do some of this prevention research. And so we're trying to really maximize the efficacy with minimizing the amount of effort that the teachers are required to do. So back to the animal lab. This is the technique that I was using until very recently to try to reduce impulsive choice in rats. And it was called delay exposure training. And what it involved was this prolonged operant training with a delayed reinforcement contingency. So the rat presses a lever, and then a cue light comes on in the chamber during a delay. And after the delay, 2 pellets of food are received. So it's very simple. And when we did that over the course of many experiments, what we found was an increase in larger later reward choices in those rats who had been given delay exposure training. Now, the control groups there, one of them is an immediacy exposure training group, so that rat presses the lever and they immediately get the 2 food pellets. And the no training group, that's a group that just sits fallow for the same period of time as the training. So it was working. It was beautiful. I mean, the data are great, in my humble opinion. But there were problems. And one of the problems with delay exposure training was it just took too long. So the vast majority of our studies, we were doing 120 sessions of training, and every one of those sessions was 80 training trials per session. And so one of my graduate students, Renee Renda, she did her dissertation to find out what's the minimum amount of training that would be necessary in order to produce clinically meaningful reductions in impulsive choice. And she found it was 60 sessions of 80 trials each day. And so it was just, it's not practical. And then I was, around the same time, I was doing research with Sarah Pinkelman, who's at Western Michigan University, and we were trying to take some of delay exposure training and translate it to a preschool setting. And, you know, we got some good results, but we had to do one-on-one training with the kids. It took very long, not 60 days, but it took very long. And it just wasn't scalable. So we went back to the drawing board. Now, around this time, we were publishing another delay exposure training experiment. And so we had the 3 groups, the delay exposure group that I previously described, and the other 2 groups as well. And we got the usual outcomes where the delay exposure group was making more self-control choices, and the other group was making more impulsive choices relative to them. But in this experiment, we included an escape from delay signaling stimulus condition. So what we did was, on forced choice trials for the larger later reward, when the rat went over there and pressed the lever, the usual consequence occurs. They get a a delay signaled by a Q light, and then they get the 3 pellet reward, which is the larger later reward. But we also put a second lever in the chamber. And if the rat pressed that lever, the only consequence of that was it turned off the Q light. And so this experiment was designed to figure out, is that Q light that signals the delay, is it aversive? If it's aversive, then they should press that lever to turn off the aversive delay signaling Q light. So we predicted that the delay exposure group would press that lever infrequently. And sure enough, that's what we got. But what we also got that we didn't expect was when we allowed the control groups to press that lever to turn off the delay signaling Q light, they became more self-controlled. And so it got us thinking about the aversiveness of delay signaling stimuli. So they press the lever for the larger later reward, this Q light that comes on, and it says, you have to wait. And then we were like, okay, well, that's kind of like a delay signaling stimulus for a child. Honey, you need to wait. Well, what does that mean? What does that signal? It sounds sweet enough, but it's kind of aversive. It means that you're about to be ignored for a period of time. It also means that your brothers and sisters might be able to cut in front of you in the queue. And it's also possible that the adult who told you to wait is going to forget about you, and you're never going to get what you wanted in the first place. So we started thinking then, we're like, okay, well, what if we could make the delay signaling stimuli not only not aversive, but what if we could make it actually a good thing? But we need to do this in a way that is efficient and effective, and even better if we could do it, train a lot of people all at the same time. And so we thought, well, that sounds great. How in the world are you going to do that? And then we decided to try appetitive Pavlovian conditioning. Pavlovian conditioning, under the right conditions, is fast acting. So what this shows on the y-axis is the how many trials that are required in order for the conditioned stimulus to elicit the conditioned response. And on the x-axis is the CT ratio that I can talk to you later about if you're interested. But the point of the slide is that if you arrange the training conditions right, you can produce Pavlovian conditioning in just a couple of trials. Well, that sounds a whole lot better than 120 experiments with 80 trials in every single session. And so we're going to try Pavlovian conditioning. It's also very low effort relative to what we were doing before, and anything that might be done in a school setting, because Pavlovian conditioning arranges response-independent events, which means you don't have to monitor the performance. You don't have to, no consequences have to be delivered contingent upon the response. You just arrange a conditioned stimulus and an unconditioned stimulus that follows, and you get the conditioned response that you want. It's so low effort that you can see that Pavlov is sitting down. So there's many ways that you might be able to use an appetitive conditioned stimulus to try to reduce impulsive choice, but I'm just going to talk today about one way, which is to deliver that appetitive conditioned stimulus as a conditioned reinforcer for choosing a larger later reward. Okay, so this is a paper that was just published by my graduate student, Katie Garland, and myself. We had 40 rats in it. Half of them were female rats. And this is the front wall of the chamber. A lever comes out. A few seconds later, a couple food pellets come out, and that's it. They're all response-independent events. This happens once on average every 120 seconds in the Pavlovian training group. The unpaired group, they received the same exposure to the lever, the same exposure to the pellets. It's just that they never occur in close together in time. So what develops when you do this over just a few sessions? We did 8 sessions of this in the Pavlovian training group, and a total of 192 trials. And so what happens is the rats are attracted to the lever. And so the PCA index, that's the Pavlovian conditioned approach index. And it tells us how much are the rats attracted to that lever. The unpaired group is not attracted to the lever. And so then we put the rats into the test of impulsive choice. So since we're using the lever as a conditioned stimulus, as the reward, if you will, for choosing the larger later reward, and as the stimulus that signals the delay has begun. Now, for the Pavlovian trained rats, when they see the lever and they learn that the delay has begun, they love the lever. They're okay with the lever during that delay. So that's what it looks like here. So here's a Pavlovian rat nose poking. They get their beloved lever during the delay to the larger later reward. And the effect of that is that larger later reward choice is significantly higher in the two conditions that it needs to be significantly higher. And the data to the far right is a replication 4 months after the training. So the rats sat fallow for 4 months, and we put them back in the impulsive choice test. There's no asterisk there because it just missed statistical significance. So we've replicated this basic effect in another study. And in this next study, we were interested, what's the function of the unpaired stimulus? Because an unpaired stimulus can have an aversive function that may have put the rats off of the larger later choice. So we used a truly random control group. And although there's a slight difference between the TRC and the unpaired group, it's not significant. But there is a significant difference between those two groups and the Pavlovian group. So I'm going to now transition to talking about some preliminary work that we've been doing in kindergarten classrooms, trying to see if we can produce this Pavlovian conditioning effect, just the building, the first building block of this, by arranging Pavlovian conditionings and just doing them across the entire classroom. So it would be like if this was the classroom, you're all in it. There would be a conditioned stimulus that occurs, and then afterwards we would all get to have a dance party together. Okay, so the conditioned stimulus is one of these Amazon Echo things that makes a loud enough noise, and it presents a conditioned stimulus, which in this case is the CS plus, and then we all get to have a dance party or a bubble party or something like that is what the kids get to do. And we do 2 of those per day. So the teachers are, they don't have to do much of anything other than have fun with kids. They don't know when the CS event is going to occur because we found early on that if the teachers knew when it was about to occur, they'd give it away and ruin it, and the kids wouldn't have any of the conditioned responses that we wanted. And then there's 2 CS minus events as well in the classroom. So that's just a different sound comes through the speaker for the same duration. It's just that nothing good ever happens following that one. So this shows the results with typically developing kids who were in the classroom. This is an inclusive classroom, which also had children who had special education referrals and some children that had autism spectrum disorder. And the graph on the left shows condition attention to the CS plus versus the CS minus. And you can see elevated attention directed to the CS plus relative to the CS minus, which is a Pavlovian conditioned attention effect. So whereas the rat that loves the lever will actually go to the lever and chew on it, humans won't do that, and kindergartners are not allowed to get out of their seats. So the best they can do is look in that direction. The other graph shows positive emotional responses that the kids have when they hear the CS plus relative to the CS minus. So in the typically developing kids, we get a good effect there, but with the special ed referral kids and the autistic kids, we did not. We can talk later about that if you're interested. So my collaborator, Rick Colombo at the University of Washington, came up with an idea that could we use the CS Plus and see if we could increase the amount of effort or work that the children do in an academic task. And so he created this task where the kids just traced letters. And then he gave them choices between, would you like to have a small reward right now for no effort or a larger reward if you complete this stack of letter tracing cards? And so if the child chose the letter tracing task, then we would increase the amount of work on the next trial. Did about 5 or 6 trials and ended up with these data. So this shows the final work requirement that the kids were willing to do in the presence of the CS plus relative to in the presence of the CS minus. And you can see that they were a little more willing to, this is the typically developing kids, a little more willing to work in the presence of the CS plus relative to the CS minus. Now, I don't want to paint this as super rosy because there's been several failures to do this. I'm kind of learning as I go about how to do Pavlovian conditioning on a class-wide basis. And so this is another kindergarten we tried to do it in where we did not have good effects. It might be because of the children were diagnosed with impulse control problems. It might be that we used only one Pavlovian training trial per day. We're not exactly sure. But there is a difference between Pavlovian performance and Pavlovian learning. And so after this unsuccessful demonstration of Pavlovian performance, we wanted to find out, did they learn anything? And so we tested them in this way where we took all the kids who were our kids with the impulse control problems. We put them in one group of children over here, and another equal group is over on the other side of the classroom. And then we brought out this awesome new toy that the kids had never seen before, and we gave it to the other group that did not have the children with impulse control problems. And we wanted to see how much problem behavior would this cause. Somehow we got the teachers to sign on to this. And so for the group that did not get the toy, we gave them the CS Plus on one day. So you sit here and wait, but you get to listen to the speaker play the CS Plus sound. And on another day, we did it with the CS minus. And so again, this is very preliminary data, but this shows the proportion of observation intervals in which we saw problem behavior occurring, and it was higher in the unpaired stimulus days. So this is very early work, and we have a lot of work left to do. And so we need to explore methods to increase the efficacy in the non-human lab, and we've got a couple of experiments going on with that. And then we need to translate those findings into effective and efficient classroom settings. Thank you very much for your attention.
All right, our next speaker is Dr. Roberta Freitas-Lemos from Virginia Tech.
Okay. Well, good morning, everyone. I'm very excited to be here and share a little bit of what our lab has been working on. I'm going to break this presentation into 3 parts. So I'll start with the experimental tobacco marketplace, a model that we use for understanding how consumers respond to market level changes. Next, I'll talk about menthol cigarettes and what we've learned about bans on these products and their interactions with flavored e-cigarette bans. And then finally, I'll discuss emerging menthol flavored accessories, products that can bypass bans, and their potential impact on smoking behavior. So here's a little background on the development of the experimental tobacco marketplace. We know tobacco use today is far more complex than just smoking cigarettes. People have access to many different products, from traditional cigarettes to vapes and other non-combustible options. Some individuals may switch between them, use more than one product, and this diversity can also make quitting more challenging. Understanding these patterns and how they influence health outcomes is a major challenge for tobacco control and regulatory science. So one important aspect to consider is that the emergence of new products and technologies significantly alter the relative reinforcing efficacy of each product. And this study aims to illustrate this impact, and the same study that Matt just showed you. This is a methodology that requires people to come to the lab and work to get cigarette puffs and other products in daily open sessions. On the y-axis, you can see the number of self-administrations, and on the x-axis, the unit price of cigarette puffs. So in phase 1 here, as he has showed you, they examine the demand curve for cigarettes alone. And as we progress to phases 2 and 3, we see demand and substitution curves when both gum and denicotinized cigarettes are concurrently available. And finally, in phase 4, all 3 products are available together, and that reveals shifts in the gum substitution profile when the denicotinized cigarette is introduced. And this study really showcases the dynamic nature of consumer preferences and how availability of new products influences substitution patterns. So in addressing these challenges, Dr. Warren Bickle first established the experimental tobacco marketplace, and I have been helping refine and improve this model in the past 6 years. And this empirical model enables us to anticipate the impact of population-level strategies on patterns of tobacco purchase among various types of tobacco product consumers. And it's really a tool for pre-implementation estimation of the effects of diverse strategies on population scale. So let's look at all the things that we can explore with this model. Here's what we call the ETM space potential. We can investigate several policies, those related to new or banned products, health communications, product ingredients, and taxation, for example. And these are just big policy categories that may include several others. We can look at the effect of policies on demand and substitution across products or across markets, such as the legal and illegal market. In different groups, including different user types, those who exclusively smoke or those who use products concurrently, or even different countries. And this is what the ETM looks like. It's a digital store in which we can place a mix of products, prices, and policies under experimental control. Participants are given an experimental budget that is equivalent to their usual expenditure with tobacco products, and then they are asked to make purchases for a specific number of days under certain conditions. They add products to their cart, they review their cart, and then they place their order. So in behavioral economic studies, like most of the ones we do with the ETM, we often increase cigarette price, and this allows us to better understand the economic relationships between cigarettes and other products. And here are 4 key measures of this approach. Again, Matt just talked a little bit about them, but demand intensity, how much someone wants a product when it's highly affordable. Demand elasticity, how sensitive purchasing is to changes in price. Substitution, when an increase in the price of one product leads to increased use of another product. And complementarity is not in the figure, but it's another measure that we've been exploring. So when an increase in the price of one product leads to a decreased use of another product. So why is this framework relevant for policy? It shows how people adjust their behavior in response to policies. It measures the relative reinforcing efficacy, how strongly tobacco appeals and how users might defend their consumption. And it reveals whether users switch products, combine them, or reduce use in response to policy changes. So just to wrap up this section, I wanted to highlight some of the key insights and applications we can achieve using the ETM. So first, the ETM is highly adaptable to diverse research questions. It allows us to simulate real-world purchasing under virtually any policy scenario and can be tailored to test single policies or combinations. And that helps us understand whether effects are additive, subadditive, or even super additive. It also supports a variety of experimental formats. We can conduct in-lab studies with real product exposure or run remote hypothetical studies for large samples, which are ideal for equity-focused research, for example. And the format can be chosen really based on the study needs, whether the priority is understanding toxicant exposure, for example, population reach or behavioral depth. Also, the ETM can be used to optimize policies by systematically adjusting the parameters to maximize impact. So, for example, we can try to find out what's the optimal e-cigarette nicotine cap that might promote harm reduction and prevent escalation of use among youth. The ETM can be applied across contexts, which allows us to simulate the same policy in different localities, and this helps us assess how outcomes might vary depending on cultural, behavioral, economic, or enforcement differences, for example. It also helps us evaluate policy transferability, so how a policy that works in one jurisdiction might perform in another. And this is critical for identifying which effects are generalizable and where local adaptations might be needed. And then finally, ETM-generated demand data can be integrated into population models, and this supports modeling of equity impacts and policy trade-offs, and that provides evidence to guide large-scale tobacco control decisions. Okay, so now let's move to the second part of this presentation. And in this section, I wanted to showcase some of the work we have done with Warren using the ETM to study flavor-related policies. So just to give some context, right? So we know that the role of flavor in tobacco is well established. Menthol cigarettes reduces the harshness and irritation from nicotine, making them feel smoother and easier to smoke. And this contributes to higher initiation, stronger dependence, and lower cessation rates. These behavioral effects result in longer lifetime exposure to toxic chemicals, and that increases cancer risk. As of 2022, menthol cigarettes accounted for 36% of the US cigarette market. And menthol use is particularly prevalent among those with lower socioeconomic status, LGBTQ+, individuals, African-American and Hispanic populations, women, and in youth. So our first question was how a menthol cigarette ban would affect demand and substitution across products. We also wanted to see how an e-cigarette flavor ban alone and combined with a menthol ban might influence those patterns. So in this first study, we used within subject design to conduct an in-lab study in a group of 25 individuals who smoked menthol cigarettes. We tested their purchasing behavior across 4 different conditions using the experimental tobacco marketplace. So both cigarette and e-cigarette flavors restricted, cigarette flavors restricted only, e-cigarette flavors restricted only, and then both of them unrestricted. And then we increased prices of cigarette prices across trials. So here, we converted all product purchases into milligrams of nicotine purchased to standardize this data. So on the left, you see the figure when we fit the full model, and on the right, when we ran a model selection. So the final model for cigarettes included an interaction between cigarette price and cigarette policy. And that shows that under cigarette policy restrictions, lower cigarette prices were associated with a greater reduction in cigarette demand, and that's exactly what we should expect. For e-liquid purchasing, the final model included an additive effect of cigarette price and cigarette policy. So overall, higher demand for e-cigarettes was observed when cigarette prices were higher and when cigarette flavors were restricted. And here we observed a clear substitution effect. So when cigarettes became less appealing due to the higher prices, participants shifted toward e-cigarettes. For NRT, the final model included e-cigarette policy only, showing that higher NRT purchases when e-cigarette flavors were restricted. And what's important here is that NRT didn't behave as a substitute for cigarettes. It was not responsive to cigarette prices, which suggests more of an independent profile rather than substitution. And from a policy perspective, this is where behavioral economics becomes really important. So cigarette taxes or flavor restrictions in cigarettes alone are unlikely to increase NRT use, but instead we may need coordinated policies. So for example, restricting flavored e-cigarettes combined with making NRT more accessible or attractive could encourage smokers to turn to the cessation tools. So the key takeaway here is that flavored e-cigarette restrictions might indirectly support cessation by nudging some smokers toward NRT, but cigarette price policies by themselves won't achieve that shift. And just for completeness, for oral products, the optimal model was the null model. So that indicated that none of the variables significantly impacted oral tobacco purchasing behavior in that data set. So next, we were interested in understanding socioeconomic disparities in tobacco purchasing. So we know that cigarette smoking is a major driver of health disparities, accounting for over 30% of socioeconomic gap in life expectancy. There are several challenges to reducing these disparities. We know that the tobacco industry has historically targeted lower SES communities with advertisements for flavored products. And we also know that flavored products are associated with increased dependence and poor cessation outcomes, as I just mentioned. So one of the most important questions we wanted to answer was, can flavor restrictions actually promote health equity by reducing differences in tobacco use between lower and higher socioeconomic groups? So we ran another study that was remote and hypothetical. We recruited 280 individuals, and each participant completed the same 4 conditions. We used the same 2x2 matrix from the previous study. And participants were categorized into lower or higher socioeconomic groups based on their education and income levels. So we looked at 4 product categories that you can see in the legend. Negative values mean lower SES individuals demanded more of that product compared to higher SES, while positive values mean they demanded less. In the middle between the dashed lines, I'm calling it the equity zone because there were no significant differences between the groups. And on the left and right, outside the dashed lines, we have inequity, where there was significant differences between the groups. So first, we can see that we reproduced existing disparities under an unrestricted policy environment with lower SES participants purchasing more cigarettes and fewer alternative products. But the key finding here is that only restrictions on cigarettes alone, essentially the menthol cigarette ban, reduce disparities. So from an equity standpoint, this suggests that menthol cigarette bans could help close socioeconomic gaps in tobacco use more than other flavor policies. So this is encouraging that disparities decrease with the menthol ban, but we need to look at how the gap is being closed. So ideally, lower SES individuals cut back on cigarettes while higher SES groups stay the same or also reduce, showing that the policy benefits those at higher risk. But the gap could also shrink if higher SES groups smoke more while lower SES use stays the same. And that would be a concerning outcome. So in this figure, we are showing the difference in purchases between unrestricted and restricted conditions for each group. So values to the right mean participants purchased less of that product under restriction. Values to the left, they purchased more under restriction. Triangles are cigarette restrictions, circles are e-cigarette restrictions. So when we looked closer at the 2 SES groups, we found that lower SES participants purchased fewer cigarettes and more NRT when cigarette restrictions were in place. And the policy did not significantly impact purchasing among the higher SES group. So here is a summary of the key things we learned from these 2 studies. So first, flavor restrictions definitely change purchasing behavior, but the effects aren't the same across all products. So for example, menthol cigarette bans lead to a decrease in cigarette demand and an increase in e-cigarette use. In contrast, e-cigarette flavor bans tend to increase purchases of NRT. And we need to consider the equity effect. So menthol cigarette bans alone may help reduce socioeconomic disparities in tobacco use. But pairing these bans with affordable and accessible NRT options could further reduce inequities and support quitting among lower income populations. So these two studies, as I mentioned, were done when I was still a trainee, 2019, 2020. And I wanted to show now how the introduction of new products may be changing the landscape and how these changes could influence the outcomes of a menthol cigarette ban. So more recently, 2021, 22, we learned about the new product in the US market, so the menthol accessories, which are non-nicotine products. And these products have become a growing loophole in places where menthol bans are enacted, allowing users to add menthol flavor back to non-menthol cigarettes. These are some of them, a lot of them available in Europe. If you're curious, you can actually find this product on Amazon. This one is a crush ball. Interestingly, they are no longer, we've been tracking them, so they are no longer marketed in the US as products to be used with cigarettes. And here, as you can see, they mention they are to be used with face masks, air freshening, and that kind of stuff. But if you look at other countries, and this is Amazon in Germany, you will find the same products being advertised with clear instructions to use them with cigarettes. So in the UK, for example, post-ban sales reached $430 million with about 900,000 cards sold every week in July 2021. Use of these products, especially high among youth and young adults. About 72% in England and 52% in Canada started using these products after bans. Adults aged 25 to 39 and non-white populations are also more likely to use them. These accessories can keep people smoking and exposed to harmful chemicals so that they may extend cancer risk even when menthol cigarettes are banned. In the US, a few local areas have restricted menthol cigarette sales, including localities in Colorado, Illinois, Maine, Minnesota, Ohio, Oregon, and Washington, D.C. And only a couple of states, Massachusetts and California, have implemented bans that also cover menthol-flavored accessories. Evidence on menthol accessories is extremely limited in the US. There's one study that was recently published less than a month ago by Christina Kariakos, where they found that while about 40% of adults were aware of these products here, when they learned about it, over 80% said they would try. They would consider using them if menthol cigarettes were banned. However, this study did not experimentally isolate accessories availability to understand its impact. And we think there are a few things that we still want to know, and we think it's important. So whether people would actually purchase and use them in the context of other products available, whether they truly mimic the sensory and reinforcing effects of menthol cigarettes, or what would happen with those willing to use them if accessories were banned. So we think the answer to these questions are necessary to assess the long-term impact on smoking behavior. So our lab is running a series of pilot studies to explore this question. We started with this one. So would individuals who smoke menthol cigarettes be interested in using accessories under a menthol cigarette ban, considering the other products available on the marketplace? So for this study, we used a within subject design conducted online, and we recruited 140 individuals who smoked menthol cigarettes. Each participant completed 3 conditions with just one trial each, so we wanted to know if they would purchase or not. The 2 conditions with like no ban, one with a menthol cigarette ban only, and one where both menthol cigarettes and accessories were banned. So when menthol cigarettes were banned, about 61% of participants, let me see if I have, chose to purchase menthol accessories. When both menthol cigarettes and accessories were banned, participants were less likely to use only cigarettes and more likely to switch to non-combustible products. When we look at the budget allocation, we can see that in more restrictive scenarios, participants shifted spending toward vaping products, nicotine pouches, and nicotine replacement therapy. And overall, their total spending on tobacco products decreased under these conditions. Our next research question was, can menthol accessories replicate the sensory and reinforcing effects of menthol cigarettes when added to non-menthol cigarettes? So we're still collecting data for this one. We also used a within subject in laboratory design. We so far have collected data from 10 individuals. Participants completed a blinded sampling session, and we collected subjective measures, purchase tax, and the same experimental marketplace trials. We also assessed ease of use for these accessories. So when we look at the MCQ subscales, we observed stronger negative reinforcement and greater stimulant effects for menthol cigarettes, and as well as for non-menthol cigarettes mentholated with the crush balls. We think that the exposure time that of the cigarette to the menthol card may not be sufficient, so we are currently only testing 1 hour. And this is a variable we might want to investigate in a different study. So the timing of exposure to the menthol cards. When we look at cigarette demand task, we with all cigarettes alone, so these are single items, and we just combine them in the figure. We see overall demand is higher in the less restrictive scenarios. And we are looking at Q0 on the top right and alpha on the bottom. And the ETM data so far mostly replicate the same orderly effects that we saw in the hypothetical task. So after actual product exposure, the patterns of use seem to persist. We also assessed ease of use. So participants rated the aroma card as easier to use than the crush balls. With the aroma card, you simply insert the card in the cigarette package and leave it there. So our next question was, for those who use menthol accessories, would a ban on this product help them transition away from cigarettes? And this is very recent data. And we started exploring this after conversation with Dorothy, actually. So we asked this because it's possible that users might simply continue smoking on menthol cigarettes, in which case a menthol accessory ban alone might not be effective. So for this study, we used this within subject design again, online. We have 60 individuals so far, still collecting data. Participants completed the same 3 conditions, but now we are increasing cigarette price across trials to understand the economic relationship between the products. So in this sample here, 32 participants out of the 60 participants purchased accessories when accessories were available. And this, I'm showing you a subset of the data. We also observed that 7 participants switched to alternative products, and 21 continued smoking non-menthol cigarettes, didn't purchase accessories at all. And this plot here highlights 2 key points. So first, it shows the complementary relationship between cigarettes and crush balls. You can see in the light green curves there when non-menthol cigarettes and accessories were available. And second, for those who purchase accessories when they were available, a comprehensive ban on both menthol cigarettes and accessories may reduce cigarette consumption and support a transition to vaping products or NRT. So this is very preliminary. We haven't ran any stats on this. We are still collecting data, but we think there's a lot there to explore, and we are very excited about this line of research. So just a few takeaways to finish this presentation. Menthol accessories may recreate or approximate the sensory experience of menthol cigarettes. They may increase the reinforcing value of cigarettes. At the same time, using these products may add response costs, such as extra time or steps that we need to explore and understand better in which conditions individuals would use these products. And overall, menthol accessories have the potential to undermine the public health impact of menthol cigarette bans. Just wanted to acknowledge those who have contributed to the work, and thank you.
Thank you, Roberta. I'd like to thank all of our speakers, Matt, Greg, and Roberta, for their wonderful talks this morning. And now we have some time for a question and answer session. I'd like to remind everybody to, if you have a question, please use the microphone so the people online can hear you. And if you're online, please submit your questions through the Q&A, and Chris will ask them for you. So please go ahead and ask questions.
Fantastic talk from all three of you. I have a question for Dr. Matthew Johnson. For your greenwashing effect, did you probe that and kind of reasons why? Was it reduced estimation of harm because of the natural simplicity of the product, or kind of an environmental effect?
Yeah, so we did pick up, we had some questions, and this is. Okay, all right, let's see. Hopefully that works. Yeah, so we did ask some questions at the end, and so we replicated this, the idea that they perceived less harm. Beyond that, I think it's only speculative. But that's probably probably the biggest thing. I could imagine also, I mean, someone just feels like they're helping to save the planet, like
One
smoke more
cigarette at a
cigarettes,
time.
save the planet, like it's a good thing.
Thank you.
Thank you for your talks. This question is for Roberta. So it's very alarming to see the impact that these menthol accessories have in terms of undermining the effects of a potential menthol ban in helping people transition away from menthol cigarettes. I'm curious, is there any evidence to suggest that a menthol ban in the absence of an accessory ban would have any positive public health impact in terms of reducing the amount of people who are not established smokers from becoming established smokers via menthol cigarettes? Like, what I'm saying is, like, is the extra step of it's not just I have to, I'm not an established smoker, I'm going to go to the gas station, I can only get non-menthol cigarettes. And if I wanted a menthol cigarette, that extra step of going on Amazon and waiting for 2 days shipping is enough to deter me from that and would reduce my likelihood of becoming an established menthol cigarette smoker.
A lot of studies on menthol accessories. Most of them have been published with data from Europe. I think that's a very relevant question. We've been thinking about what role that plays, for example, with delay discounting. Since they have to wait to mentholate their cigarettes with the menthol cards, for example, the crushables are much simpler in that sense. So you can get a menthol cigarette right away.
Right.
No, I think that's a relevant variable to investigate, but there's no data about that.
Thank you.
Hi, hi. Great presentations from all the speakers. I have a question for Greg. So I really was interested in your Pavlovian conditioning manipulation. So my question is it correct for me to assume that your conclusion was that in kids with impulse control problems, that the manipulation didn't work as well?
Yeah, it didn't work as well for the conditioned responses that we were measuring, which was the positive emotional response and the attention to the CS plus relative to the CS minus. However, when we tested them in sort of a remain patient for your turn to play with this toy, there was some evidence to suggest in 2 classrooms that it improved their patience. Even though the Pavlovian conditioned response wasn't occurring, it did seem that they learned the Pavlovian relation between the CS and the US. Indeed, one day we asked them, if you think the US is going to happen, raise your hand, and the vast majority of the kids got it right, following CS plus and CS minus.
Yeah, I was just trying to figure out how to apply it to, so I work with people who use opioids illicitly, and I just, do you have any thoughts about how you might apply those kinds of techniques to that population?
Yeah. I haven't thought about it. So nothing comes to mind at this moment. Yeah. We're trying to do the prevention work with young kids, and yeah. Sorry.
This question is for Roberta. I was just wondering if the tobacco marketplace has been used at all to compare product switching among like certain populations, like people with mental health conditions or disabilities in general, just like if there's more hesitancy to switch or anything like that based on the cost of cigarettes.
Besides the work that we did with lower and higher socioeconomic status, I haven't seen any comparison with that.
Interesting. Thank you.
Hi, great presentations. I have a question, well, a comment for Greg. I'd just like to hear your thoughts. So, and I want to make sure that you understand I'm not discouraging the work on Pavlovian conditioning, but I'm trying to rescue the operant conditioning a little bit. So what I was thinking is, we talk about delayed discounting and I think appropriately so, as a really problematic, steep discounting, a problem that sets you up for potential smoking, heroin addiction, gambling, and then I was thinking, like, well, how much time do we devote to teaching kids the ABCs? Lots of time, lots of replications and what. So I guess what I'm encouraging you is maybe a blend, and not to underestimate the importance of the kind of training you're doing in terms of protecting the kids longer term. So just your thought.
Yeah, I think that's a good point. I think that I sort of view the Pavlovian conditioned stimulus as almost a helping tool. And so it could be deployed by a teacher, it could be deployed by a parent to help the child early on in their journey of learning to be patient and wait, because it signals the thing you want is actually coming. And it also could be used as a tool for the child to remind their parent, I'm waiting. I have the conditioned stimulus in my hand. But to your point, I think the more often the child successfully waits, essentially what we're doing is delay exposure training as a result. And so by repeated successes, I think that would be the pathway to longer term achievement without needing the tool long term. And going back to the prior question about opiate use, I was thinking about that a little bit more. I was thinking of like Nancy Petrie's fishbowl procedure. It is kind of a CS event in that you get to pull it out. It's a probabilistic CS-US relation, and so it doesn't give anything new. It just helps you to think about something that's already been done.
Greg, another follow-up. It got me thinking about second order schedules. And so a second order schedule, there's a stimulus associated with the reinforcer at the end. And then that stimulus can be, say it's not 1 hour, a delay primary schedule. That stimulus, you can press the lever for, say, 10 times, a fixed ratio, and the rats or the monkeys will really press the lever a lot. And work a lot. A cigarette, it's kind of built in. There's the nicotine, kind of a delayed effect, a little bit, but every puff you get an effect. But I'm thinking about the real world. How do you build that in to real world behavioral situations? And by the way, Steve Goldberg and I did parallel animal-human intravenous nicotine and intravenous cocaine in a second order paradigm. And the people were the same as the monkeys. They did the fixed ratios within. And I wonder if that might be a way to help bridge delays and generate behavior along the way. But Pavlovian conditioning obviously is built right into it.
Yeah. Yeah, the only comment that comes to mind, it's only tangentially related, is I think within the substance use arena, Pavlovian conditioning has a bad rap because it's only, appealed to when it's like cue effects that cause relapse and things like that. And so we're trying to stand Pavlovian conditioning on its head a little bit and showing that it's a powerful effect and it could be used for good.
Okay, we have a question from online and they ask, do you think the non-neurotypical kids were just attending to the stimulus less, or is it something deeper?
Well, we actually had the data on the attention to the stimulus, so they were seeing it. And they were differentially attending to the CS plus more than the CS minus. However, what they didn't show was a positive emotional response to the CS plus relative to the CS minus. And I think part of it, having viewed some of the videos that we took of the kids from which we coded all the data, I think it may just be a flat affect thing. And so our conditioned response may just not be appropriate for those populations or less appropriate for those populations. We need another conditioned response.
So no surprise, Greg, I'm going to tell you to jump deeper into the Pavlovian pool. In all serious, beautiful work. The question, I guess, is I was curious about what you're going to be doing moving forward to sort of increase the effectiveness, the robustness. Some things that were hit upon that make me think about some things is like CR form, condition response form is based on CS types. And have you thought about the kind of CS types you're using with the kids, and would that vary along other ways?
Yeah, we haven't thought about that yet. So thank you for that comment, and perhaps we could talk later about it. Yeah, the work that we're doing right now is we're trying to just do a parametric range of that CT ratio to find out, what is the roadmap for effective CT ratios, which may be able to inform what we do in the classrooms as well. Yeah, I mean, what we've done in the classroom with only 2 trials per day, the C is huge. And so, yeah, you should get very good conditioning there.
Plenty of time left. Don't be shy.
I'm sorry, I've already forgotten your name, the person in the middle.
Roberta?
Hi. So I was very curious, do you know of any testing on the actual chemical constituents of these menthol imparting products? And specifically, I'm wondering, like, we know that menthol can cause upregulation of nicotinic receptors. And we know that the tobacco industry used pyrazines also to make the nicotine even more addictive. And so it's like an interesting question, at least to my mind, like whether we're also finding other chemicals like acetates, which also cause upregulation and so on. But do you know of any studies on the actual chemical constituents in these products?
There are no published studies, but we just worked in collaboration with Irina Stepanov from University of Minnesota, and we have just some preliminary data that those products may be an additional source of toxicant exposure. Yeah, we do
Both
have-
toxicant and these products that actually cause increases in the potential addictive nature of nicotine?
We haven't tested that far yet.
Oh, okay.
We just have some initial testing, some preliminary
Okay,
data.
all right. Thank you.
Hi, great talks. Really enjoyed all of them. Some practical questions, one for Roberta and one for Dr. Madden. For the sensory study that you discussed with the sampling and the comparisons between conditions, could you walk through just a little bit more about how that was designed? How much time was spent sampling? How long did they have exposure to those products?
Yeah, so we did a brief review of the literature, and we decided on I think we asked them to take 4 puffs, and then we have a 20-minute washout. They are blinded, of course. The non-menthol cigarette is obvious, but the 3 other menthol cigarettes, or the menthol cigarettes and the one that are mentholated, they don't know what they're doing.
Great, thank you. Dr. Madden, I was just curious how, I know that your collaborator was doing most of this work in the schools, but I was wondering if you could speak to kind of how that collaboration worked. How easy was this to make it happen? This seems like a really kind of big lift to get into the schools. I work with some schools in Virginia, and man, I'm impressed to say, I'm impressed.
Well, the kindergartens are on the university campus, and so it's a research school. And likewise, on my campus where we did it with the kindergartners with the impulse control disorder, that was also at a research schools. I have done, that work in the past with trying to get kids to eat fruits and vegetables in schools, and that was all done in public schools. And so in order to do it, usually we just met with the principal and then would lay out what exactly we wanted to do. And I can tell you from getting no on more than one occasion that all of the things on the what an ideal prevention program would look like is low cost, low effort, efficacy, demonstrated efficacy. If you give them that, I've never had anyone say no. No principal's ever said no to, look, it's not going to take much time for the teachers. They always go talk to their teachers afterwards, but they've always come back with a positive. But I've gotten a lot of no's when I asked them for a lot of work from their teachers. They're like, look, I don't need that.
No.
I'm going to get in trouble if I ask them to do that.
Thank you.
Yeah.
It's really fun, especially coming after our session yesterday, where you're thinking about a lot of different things. But the power of contingency management, in part, it strikes me as you're bridging. So the big reinforcer being healthy or whatever, which is really, a pie in the sky concept for a lot of people. All of a sudden you're getting vouchers. What is that way of thinking about it maybe a way to be thinking about with school kids and others early on? And I'm wondering also what Steve and others in the room would think about that, because is that part of the magic of the contingency management? And I think I've seen some data that in contingency management programs, delay discount estimations improve. Is that right, or am I missing that? Anyway, I'm going to sit down and let you guys talk about it.
Yeah, these are great talks, and I just wanted to pipe in to follow up on Steve and Jack's comments about thinking about somehow combining the Pavlovian and the operant, because it's exactly right. I mean, the whole basis of addiction is the impulsive choice of immediate reinforcement from the drugs versus the sort of delayed and uncertain reinforcement of stopping your drugs. And what CM has done is to substitute an alternative positive reinforcer. Now, those kids probably have a lot of alternatives, like the dance party, right? So if there was, a training of, like some kind of a task that simulates delayed choice could be, I think, I don't know how much work that would be for a teacher, but it could be easily done. And then everybody, as the choices get more and more delayed, they get the dance party.
Yep.
Yeah, I mean, do you think that could work?
Yeah, I mean, again, so we're trying to establish a tool, and another word for that tool is a condition reinforcer. An appetitive Pavlovian CS functions as a condition reinforcer. It is the process by which a condition reinforcer becomes a condition reinforcer in non-human animals. You can establish it verbally in humans, But in non-humans, it's a Pavlovian process. And essentially verbally, you're just telling them what the Pavlovian conditioning contingency is. So the teacher can use the tool in exactly the way that you're talking about. Once the tool is established, then this is your tool to help a child to wait. If you ask them to wait, give them the CS. Now, you can't give them an Amazon Echo speaker that is blaring with the sound. This is an initial prototype that we need to figure out how to make it portable, usable, affordable, et cetera. But with repeated exposure to that, again, it's kind of like, here's a tool to help with delay exposure training, which does take longer, but that delay exposure training also produces long-lasting effects. When we've tested the rats months later after they go through delay exposure training, we see reduced impulsive choice, for a long period of time.
I don't know the answer about the delay discounting question and CM. What I recall is that that the people who are steeper discounters may use their the incentives you provide sooner than the other people, which, so that's about all I know, but it's an important question. I just don't really know the answer. And I want to take the advantage of the time we have for a discussion to revisit with Greg. You know, I was thinking some combination studies are probably in order down the road for you. And I also was reflecting on your practice of sorting the kids, which I think is really a good idea, because, you know, what you prefaced your presentation, you mentioned in your presentation, is the teachers already know a lot about these kids early on. And my wife was a middle school teacher, and we live in a small town where people don't always move out. And so we will later see a report in a local newspaper about somebody getting busted for some crime or worse. And she'll say, I had him in middle school. I knew he was headed for trouble. There are exceptions where someone turns out to be an all-star. There was, but they're much fewer than the ones where she says we knew that. So I was thinking, you know, the kids that have the problems that you've, you know, whatever I can't even remember what the characteristics were that you sorted on, but it's those kids that you need to most in need of your intervention. The kids who aren't so responsive and whatnot.
Absolutely.
So,
yeah, absolutely. Good point. Yeah. Yeah. And that's why we continue to do the laboratory research, how to make it more effective and then translate it.
I have a question for all three of you. As a non-researcher studying something that's very social, substance use, how do you measure that? I've never been in a study myself, so I don't know if that's a thing discussed, if it's a question you ask, but like how would how people's behavior, oh, it's gone. How behavior changes when you're in a social setting, when you're with strangers, when you're safe, when you're comfortable. I'm thinking about smoking cigarettes, but really for anything. Is that something you ask about and can measure?
Yeah, I mean, just say a few things. I mean, we know, certainly, I mean, you're absolutely right. I mean, there's some of these things are kind of hard to study in the laboratory, but, you know, some work has shown that, you know, for example, stimulants will increase the reinforcing effects of, amphetamines will be more attractive under conditions in which there are people to talk to. People like to talk a lot on speed. We know that drug taking behavior itself, even in rats, can be learned through social observation. Mark Smith has done some work showing that. Yeah, and there's plenty of, you know, sort of more ethnographic research showing that, as you suspect, I mean, it's no surprise that, you know, drug taking is a highly social enterprise. So I don't know if you have any kind of more specific questions, but as far as all the research to the degree that the field has been able to explore it experimentally has all confirmed what we all kind of know. Yeah.
Not about substance use, but delay discounting does seem to be impacted by state setting things. So there's a study, for example, that shows that if you assess delay discounting in a laboratory setting, you'll get different amount of delay discounting relative to if you take pathological gamblers to a gambling hall. They become very impulsive in their decision-making in that setting, unsurprisingly. Now, there is a state effect, like a context effect or a setting effect, but also there's really good evidence that it's a trait effect, a long-lasting trait in that they may behave more impulsively in this setting than this setting, but when you compare them to another individual, they'll still remain the rank order in terms of who's more impulsive and less impulsive remains pretty much the same. They all become more impulsive in this setting, less impulsive in this setting, but this person remains more impulsive than this person, for example. So the point of that is that if we can intervene early and produce this trait change that has long-lasting effects, then possibly it could serve them well throughout the rest of their life. That's the goal.
And Greg's answer prompted another thought of mine. One aspect of social behavior is sexual behavior. So that's something I studied in the context of drug use for years, including doing things like administering cocaine in the lab and methamphetamine. And with those two drugs, not surprising to people that treat cocaine addiction or to people who have dabbled themselves, but increases the reinforcing effects of sexual activity. Also makes people more likely to choose smaller sooner in the context of sexual risk behavior to have unprotected sex versus waiting even short amount of time to use a condom, because the sex becomes so attractive when people are on stimulants. So there's a pretty strong interaction that we found in terms of stimulants and sexual behavior.
And I was just going to add that there is a, within behavior analysis, there is a subfield that's called cultural behavioral analysis, cultural behavioral science. And they have some experimental models to understand social behavior. I know there's one researcher in Brazil that is trying to integrate behavioral economics into that to develop models in which they can understand social behavior within the context of substance use.
So Jack's comment about second order schedules really had me thinking, and Greg, this might just kind of applies to you. It's just a thought. Token economies, and they really are rooted in second order schedules. And one of the great about tokens is that you can manipulate multiple different schedules. You have your token production schedule, so that's just the effort required to run a token. And when you increase those schedules, you see pretty decreasing responding. But then there's that token exchange schedule where you can, once you have a token, you can kind of increase the response requirement to then produce the exchange. And when you kind of start thinning that schedule, you can still see pretty good responding occur in those lean schedules. And so you kind of train people to tolerate more delays and basically, reducing that impulsive choice. So it might be a potential avenue for you to consider. And they're super popular in schools. Kids love tokens and token boards and so forth. So just some food for thought for you.
Yeah, that's great. I love the integration with Tim Hackenberg's work. So thank you.
He was on my PhD committee.
Is that right?
Yeah.
Brilliant.
One more question for you, Greg. Something that struck me was when you were in your animal models, rats learned to love the lever. So it was an individualistic sort of component to it. in a classroom, obviously this is getting away from your general sort of premise of, well, how can we fit this in efficiently in a larger setting? But have you given any thought to echoes on each individual's desk? You know, as thinking about them as a cue for their own sort of specific, if interactions are, or if things are coming up for the honey, you have to wait sort of situations. It could be like if they had their own sort of love for a lever, would that be, any thoughts on that, or? what
So
you-
you're thinking every student would have their own little card almost that would
Right.
light up if,
Yeah.
yeah, and then that signals that the US is coming for you.
Essentially. And so like, if
Yeah.
you think about from the teacher's perspective of a utility,
Yeah.
you know, if you're trying to get the whole classroom to do something, it makes sense. But you could also create a pairing where, you know, it all lights up for the entire, if each individual has their own, then, you know, it lights up as a group. So you still get that same group
Right,
effect.
right.
But then I'm thinking about it from the teacher's perspective of if half of the group's working on some activity, the other half's working on another. If you have individualized components to it, they all have the love for their own lever,
Mhm.
and then it could be sort of fitted into a model.
Yeah.
Just something. Just think about.
Can you guys all come and work in my lab? These are great ideas. Thank you.
Great job. Can I see?